Welcome back. So let's look at this confidence interval I left you with. It's a 95% confidence interval. So the alpha we're talking about, this double arrow means implies, by the way. It's math shorthand. 95% confidence implies that the alpha we're talking about is 5%, in other words, 0.05. So the alpha over 2 that shows up in our formula is going to be 0.025. Okay, half of 0.05. Our sample size is 35. So when I look up the t-value, t sub alpha over 2, I'm going to be using 34 degrees of freedom. So let's look that up. So t sub alpha over 2, t sub alpha over 2, 0.025 for 34 degrees of freedom. Okay, 34 degrees of freedom and 0.025. So there's the 34. 0.025 is here. 34 is at 2.032. 2.032. Okay. Let's see. So that's all the numbers we need. We're ready to plug into the margin of error formula, which was t sub alpha over 2, standard deviation over the square root of the sample size. Our t sub alpha over 2 is 2.032. Standard deviation was given to us as 4.5, and the sample size is 35, so we have square root of 35 down there. Running that through a calculator, you should get 1.55. So we're now ready to construct our 95% confidence interval. So the lower bound will be x bar minus the margin of error. The upper bound is x bar plus the margin of error. We were given x bar as 18.4. That's our point estimate. That's right in the middle of our confidence interval. So minus 1.55 and plus 1.55. And again, just crunching numbers, you get 16.85 as the lower bound and 19.95 as the upper bound. So to interpret that, we can say that we can state with 95% confidence that the mean for the population will fall between 16.85 and 19.95. Okay, so I'm going to stop the video here, and we're going to come back and do an example where we're not given some of the information, some of the summary information. We're not given the x bar and the s. So we'll see what to do in that case in the next video. So I'll see you then.